So question 10. Now question 10 says, what is the shape of the conductiometric titration curve of HCl and NH4OH? Linear decrease followed by linear increase, non-linear decrease followed by linear increase followed by linear decrease, and a flat region. So we have to show this graph. So so remember, we're talking about HCl against NH4OH. Now remember, we talked about this in our study, the conductiometric class. We talked about HCl graph against NH4OH graph. That's a strong acid against a weak base. Now, so from the option, we're trying to find out how the graph is going to look like. The first option, it says linear decrease followed by linear increase. Okay, a linear decrease followed by a linear increase. Okay, now this is actually wrong. This is actually wrong because this confers for a strong acid and a strong base graph. Then B, we have a non-linear decrease followed by a linear increase. Remember, I told you how a non-linear decrease looks like. A non-linear decrease looks like something like this, followed by linear increase. Now this is wrong. This isn't how the equation looks like. The graph look like. A linear increase followed by linear decrease. A linear increase dictates this. This will be a linear increase. A linear increase followed by a linear decrease. Now this is also wrong. And lastly, it said a linear decrease followed by a flat region. A linear decrease following a flat region. Now this is the best graph. Now the linear decrease, remember the linear decrease is due to the hydrogen ion being substituted by the ammonium ion. Then it gets to the equivalent points where the hydrogen ion has been fully exhausted, as we said. Then this flat region occurs due to the common ion effect of the NH4Cl and NH4OH in the reaction, limiting the dissociation of OH in the reaction, causing a flat or a slightly increased region of the post equivalent point. So the best answer is a linear decrease followed by a flat region. Thank you.